Okay, so as a couple reminders, we've got a bunch of web work due tonight. I have some homework questions to go over. I'll remind you, there's a bunch of web work due tonight. One of them is particularly long, and I'm willing to extend the last one, but there's also some due next week. So, that's sort of the downside of having homework due once a week, because sometimes they build up on that one day. But I'm generally flexible. I'm trying to be flexible during this strange time, so I'm hoping you're working on them, but if you need some extensions, please do let me know. But, we have our test next week, so let's not go too crazy with it. So we're going to do our test next Wednesday. And if I'm not mistaken, I believe I have not assigned any homework for next week, so that we can just focus on the test. And what we'll do is on Monday, you'll also notice there's no video for Monday. So Monday, we can do some review. It's just like a purely review day, nothing I'm expecting you to have watched. No homework due that week. So, next week's full on review and the test. And Monday's particularly important, not just because it's review, but because I'd like to do a dry run of the tests format. So I'll invite you to some Google Hangouts, probably a couple different ones, and you will meet in your respected Hangout, and we will go over like how to submit the test, and I'll probably ask you to practice submitting something just so I know there aren't, you've gone through the motions and you know the process before next Wednesday, and everyone's a little stressed out about the test, right? So on the test day, I'd like you to just to be thinking about the test and the material, and not about things like how do I submit the test, or how is this going to work. Again, I'm trying to be as flexible as possible with all this stuff, so I hope you'll bear with me, and I think this should work okay, but we'll see. Let's see here, trying to get my light right. I'll just remind you one more time too that I'd like to do our final exam. So we'll have our first test, our only non-exam test on the 15th, and then we'll do our final on the normally scheduled day and time. And so put that in there in your calendar. Heard someone just asked in the chat there, can we extend the 4.1 homework to Monday? I need a bit more time for it. So I'd like to leave the due date for tonight, just for tonight. So encourage everyone to work on it. And then maybe tomorrow I'll go ahead and extend that homework. And I'll probably go ahead and extend it maybe even past Monday, maybe to next Friday or something like that to give you more time. So yes, I can extend it, but I'm not going to extend it immediately. Other sort of general thoughts about the test, or I don't know, procedural type things before we look at some material? Okay, so more information about the test forthcoming. We'll do some review on Monday, and we'll practice the sort of general format setup on Monday. So Monday is kind of an important day for you to be here. So I had a question about this problem. I know it's kind of maybe hard to read, but you're welcome to open it up on your computer or something, or just know that this is problem 2 from 4.1. So this is one of the homework assignments that's due this evening. And in this particular assignment, we're trying to see if something is a subspace. And so from 4.1, we looked at this last time, and I just want to clarify. You show something's a subspace if these 3 things hold. So the 0 vector is part of the space. If you add 2 vectors together, it stays in the space. And given a vector in the space, all scalar multiples stay in the space. And so you go through each one of those 3 things, and if all 3 are satisfied, we have a subspace. And so in this particular problem, we're being asked about the 4th quadrant. So the quadrant right here in the xy axis that's being highlighted, right? So this is like the y-axis, this is the x-axis, and so we're talking about all points down here in the 4th quadrant. And you can see it's characterized by this right here. I don't know if you can see that, but if you're in the 4th quadrant, that means that x values are positive or non-negative. I mean, it could be 0. And the y values are less than or equal to 0 in that quadrant. So the question first becomes, is the 0 vector in there? So yes, because you can just let x equal y equal 0, right? They can both be 0. They just have to be bigger than or equal to 0 for x or less than or equal to 0 for y. In other words, the origin, which is right here, right in the middle, is in the fourth quadrant, technically, because we're including the axes. So the first one would be a yes. Is things closed under addition? So I'm going to look at 2 right over here. Let's let x be greater than or equal to 0. Let me redo that. Let's pick 2 points. Let's pick a point x1, which is going to be x1, y1, and x2, which is going to be x2, y2, and we'll assume those 2 things are in quadrant 4. And so we'll assume that x1 and x2 are greater than or equal to 0, and we'll assume y1 and y2 are less than or equal to 0. All right, so these are 2 points that are in quadrant 4. Let's add them together and see if it's still in quadrant 4. So x1 plus x2 would be x1 plus x2, y1 plus y2. And since both the x's are positive, when you add them together, they stay positive. And so this new term is still greater than or equal to 0. And since both the y's were negative, they stay negative when you add them. And so this one gets a yes as well. It stays in quadrant 4 when you add 2 points in quadrant 4. And so this one is also a yes. You just pause right there and see if those 2 parts seem okay. If I can answer any questions about those 2. We haven't finished yet, but thoughts so far? I just realized that I've been recording this video, but I haven't not able to see it on my screen. I need to fix that quick. Hold on a second.
Professor.
Yes.
So when you mean by yes, does it also mean that it is closed under addition?
Yeah, so when I mean, so the question says, is it closed under addition? And the answer to that is yes. So yes, it's closed under addition.
Okay, thank you.
Other thoughts about that before I do the last part? If you're watching the video later, I apologize that it was a mess up at first, but I fixed it. Okay, so the third part says, is it closed under scalar multiplication? So for part 3, slide my paper up a tad here. And I'm having a hard time with the light in here, I think. Let me see if I can adjust that quick. That's the best I got, unfortunately. Maybe I could do this, actually. Sorry about that. One moment. Just trying to block out some light. That's not going to work very well. That's the best I got. Sorry. Anyway, let's pick a vector in the space. In quadrant 4. And what happens when you multiply by a constant? Like, this is something we learned about early on when we were talking about vectors. When we were first learning about what vectors were and how they worked, we had talked about what happens when you multiply a vector by the constant. What are some of the things that can happen when you do that? So if C is, yeah, go ahead.
It could get like stretched or compressed, right? Like depending on how you scale it.
Yeah, exactly. So if C is bigger than 1, it stretches X. If C is between 0 and 1, it compresses it. And both of those things are going to keep it in the space. Like if this vector is some here in R4, in the quadrant 4, I mean, if we stretch it out, it's still in the space. And if we shrink it down, it's still in the space. But what happens when C is negative? If you multiply by a constant that's negative, what does it do to that vector?
It changes its quadrant.
it flips the direction, so which will change the quadrant, right? So if C is negative, it reverses the direction of x1. In other words, if this is our vector in the fourth quadrant and we multiply by negative, it's going to flip it around and make it over here. And that's not in the space anymore. And so part 3 fails when you multiply by negative constants. And so for number 3, is it closed under scalar multiplication? No, and the reason is because if the constant is negative, it leaves quadrant 4. And so we get 2 yeses and a no. And so we need all of them to be true. And so the final thing is it a subspace? The answer is no, because 2 failed. I'm sorry, 3. So that one was a little tricky. When I was first looking through it, I was thinking it might have been. Not thinking too hard about negative scalars. But when you multiply, hopefully that makes sense. When you multiply by that negative scalar, like I put in the picture, it would actually flip the vector around and remove it from quadrant 4, which means it's not closed under scalar multiplication. Having said that, one of the problems, if I'm not mistaken, or a question that could be asked, even if it's not one of the problems, is the union of those 2 quadrants. So if we did the union of quadrants 2 and 4, then it would be a subspace because flipping it around would keep it inside the space. Like if we included quadrant 2, we'd be okay. And so if I remember correctly, that's like a common kind of question where you do one or not the other. Yeah, so problem 3 has this quadrant filled in as well. And so 3 is not going to fail in that one. 3 is they're all going to pass in that case. I'm sorry, wait, is that right? Oh, that's not quite right either. So a different one fails in number 3. So question number 3, this one will be okay, but number 2 will actually fail, now that I think more about that. I saw there was a question. Let me read what that said. So what should we put in number 3? So, oh yeah, so what you should enter, you need to enter a counterexample. And so the question specifically says, if it's not, enter a scalar and a vector whose product is not in there. So for example, so the answer could be 1, -2 is in the space, but -1 times 1, -2 is not. And so you would enter the scalar, -1, and it wants it separated by commas, and then the vector, so it would be 1, -2. This is what you would actually enter, for example, to get a submission. Let me make sure that that works for me, just as I don't want to lead you down the wrong path again. Oops, I entered it in the wrong one. Let me try that again. Yeah, that'll work. Other questions about this one in particular? Okay. I'd like to follow up with an error I had last time, and thank you, Sydney, for helping me realize I messed this one up when I explained it. So this is something from last time when we met, and this is 4.1 number 15. And I had messed up my explanation of this, and so if you had tried to answer with what I told you, you probably weren't able to. And so I apologize. Here's the correct answer. So it's another similar question to the one we just did, except our space that we're considering in this one is all the set of matrices such that when you raise them to some power, you get the 0 matrix. And so what we had said was, well, the 0 matrix is in there because you can raise the 0 matrix to any power and get 0, so that was okay. I went through some intuition kind of things to maybe decide that it's not closed under addition. But when I tried to do a counterexample, I actually messed this up. And so I had claimed that this U and this V are in the space. And I thought they were in the space because I was sort of thinking kind of quickly that when you square this one, you get 0, 0. But that's actually not true. And so let me re-explain. So what I had said was, hey, this is something that's in the space, and this is something that's in the space. But when you add them together, you get the identity matrix, and that's not in the space. And so this part is true. When you raising the identity matrix to any power, it isn't going to change it. But it turns out that this is the first row is not true. So if you square this matrix, the 1 stays right there. And if you square this matrix, the 1 stays right there. And so these two things are actually not in the space. And so the second part was true, but I didn't actually pick correct matrices that were in the space. I just tried to do this one on the spot, and I messed that one up a little bit. And so let me maybe fix that part on the back here. So this is 4.1, number 15, part B. 2 vectors that we could use that are in the space. Let me just make sure and remind myself the question here. I think would be this. So I put the 1 in the wrong spot. Now those are matrices. So if I squared that one, you would get, let's see, upper left, you get 0, upper right, you get 0, lower left, you get, yeah, so those work. But when you do U plus V, you get the ones on the other corners, and this is not in the subspace. And so these, and when you enter this question, just like you want to do in the last one, you need to enter a counterexample. And so your counterexample would be this matrix and this matrix. I'm sorry that I messed that one up last time. This is one of the reasons that I want people to send me questions ahead of time. So I've never done these problems before because I've just assigned them. I'm just going through and assigning them now. And so when I do it on the spot like that, sometimes I might mess it up. So I apologize, but this should be the correct answer that will get you the points. Because if we raise this to a power, it won't end up being the 0 matrix, basically, is the short of it. So I didn't intend that one to be that tricky. I apologize. I think the other matrix ones maybe are, I hope, a little more straightforward. I'm not really sure, though. Can I clarify something about that? Someone in particular had asked me, oops, that question. And I just want to make sure that that seems okay. See a question about number 10. Let me see what 10 was. I see. Yeah, that one's a little bit tricky too. So 8, 9, and 10. I got them right, but I'm not sure why. Okay, let me just look at them again. Doing them on the spot may not be beneficial for everyone, so let me take a minute and look at them. In the future, I would really strongly encourage you to ask these questions ahead of time. That's why I try to send out those emails ahead of time. Okay. So number 9 is the one that just popped up first. This one seems doable very quickly. Let me get another piece of paper. So number 9 says, this is 4.1, number 9. says we have vectors in R3, so A, B, C, where all the entries are bigger than or equal to 0. So this is like sort of like quadrant 1 in R3, so to speak. And so what it's saying is we have some arbitrary 3×1 vector, but all the entries have to be positive, right? Or non-negative. They could be 0. And so part A says 0 in there. Well, they could all be 0. And so yes, A equals B equals C equals 0 satisfies that definition. So the 0 is in there. It's kind of strange that it asks the subspace question second. Usually that should be the third question. I'll try to remember to fix that. I think we should do C and D first. So C asks for scalar multiplication. D asks for addition. And so let's multiply ABC by some constant vector. I mean, ABC by some constant scalar. Well, that becomes CA, CB, D. And we need all entries to be positive. Oops, sorry. So Finton asked this question, so I'm going to ask him what he thinks about this. C is some arbitrary constant, and we're multiplying each term. Is it going to make sure that all 3 of those terms stay positive for all values of C? So it seems like you got it. I'll go ahead and answer my own question. If C is negative, this is going to fail. Very similar to the one of the last ones we just did. And so this one is a no. The answer to that one's a no. It's not closed under scalar multiplication. Is it closed under addition? Well, let's add 2 vectors together where all the entries are constant. So I'm assuming these 2 things are in the space, which means their individual entries are positive. And so if we add them together, we're adding together a bunch of positive things, and so that's going to stay positive. And so that one's a yes. And so we get 2 yeses, right? 0 is in there, and it's closed under addition, but it's not closed under scalar multiplication for a similar reason that we just did in the last one. And so that means it's not a subspace because C fails. And again, I don't know why these questions are out of order like that. I didn't write this question, I just picked it. I can rearrange it though. Maybe I'll try to remember to do that if I can. Okay, 8 is sort of similar looking. 10 is kind of funky. I thought I had written down something on that one, but anyway, let's look at number 8 and maybe kind of do it a little bit quicker. So 8 is a similar problem because it gives you a vector in R3, but the condition here is that you multiply the 3 things together and get 0. And so it's all the vectors in R3, but you multiply the entries together and get 0. This means that one of those things has got to be 0. Let's just be clear about that. So that means at least one of A, B, or C has to be 0, right? If you multiply things together and get 0, one of them's got to be 0. And so it's like all the things that are on one of the axes is sort of the way to think about that, at least on one of the axes. It's basically all the axes, I guess, all the axes in R3. Again, this thing is all out of order. I don't know why. So the first question is it a subspace? That should be the last question. B, is it closed under addition? C is it closed under scalar multiplication? D is the 0 vector in it? So yeah, so I think it fails in the second one. So Finton says this one would be closed under multiplication, but not addition. Correct. Yeah. So I think it fails addition because let's say we had something like 1, 0, 3. That would be in the space because when there's a 0 there, so when you multiply the 3, you'll get 0. And let's put the 0 in another spot. That's also in the space because it has a 0, right? But when you add them together, you get something that when you multiply those 3 entries, it's not in the space. And so that makes this a no. But scalar multiplication does work. So if you did like C times A, B, C, you get CA, CB, CD. I mean, CC. And when you multiply those things together, I should use another letter other than C. Sorry about that. But you can factor that out and get ABC still, and this part equals 0. And so that's why the second part is a yes. It is closed under that. And the 0 vector, that's a yes too, right? So if you had 0, 0, 0, that when you multiply those 3 things, it's in the space, right? And so that's a yes as well. So you get yes, yes, no. And so that means the subspace is a no. Because B failed. Let's see, can I get away with not doing all of problem 10 and just explaining it? Let's see. Okay, yeah, so this is why I put 10 after 8 and 9. Because I was hoping 8 and 9 would kind of give you an idea about how these types of problems work. And then I was sort of hoping that 10 would make more sense. But maybe if I write it like this, it'll make more sense. So 10, we're still in R3. So it's all vectors that look like A, B, C, except 6A plus 7B plus 7C equals 0. That's the condition on this one. Right, so the way these are all working, it's like we have something in R3, but this is a condition on that one, right? They all have to be positive, right? We have something in R3, but the condition is you multiply them and you get 0. And then this one is you have all the vectors in R3, but they lie on this very specific plane. Excuse me. And so we go through the 3 things. So 0 is in here because 6 times 0 plus 7 times 0 plus 7 times 0 does equal 0, right? So you can have the 0 vector and it satisfies that equation. Is it closed under addition? Let's add, I'm just going to cut to the chase. If we add 2 vectors together that are in the space, it would look like this. And what happens when we do 6 times this plus 7 times this plus 7 times this? We want that to be 0, right? And so we can distribute the 6 and the 7s and rearrange what happens and make it look like this, right? So in other words, this will end up being 6A1 plus 7B1 plus 7C1 plus 6A2 plus 7B2 plus 7C2. And we know each one of these equals 0 separately because they're individually in the space. And so the whole thing ends up being 0. And so this is a yes as well. And I'll just sort of say that the part C is similar to B. So you get a yes for that one. And so that's why D ends up being yes, it is a subspace. So I just kind of flew through that one, hoping that maybe you can relate it to the other 2 and maybe go back and look at it and make some sense. But does that seem okay? I just did 8, 9, and 10 and 4.1, and I will scan this in later for you to look at. Now, this is the kind of thing you want to be doing when you write this down too, right? Like these are obviously, half of them are drop-down menus, and you could get away with just guessing on some of these. But you want to have something written down to study from for these tests. This material won't be on the test next week, but it will be on the final. Okay, great. Glad that helps for Finton. Anyone else have questions about this one in particular? I had another question from 4.2 we can look at as well, or other questions at all in general. Do people have any questions about the notes before we look at another homework question? I should have started there. I always try to maybe start with the notes and see if there's something I can clarify about the notes. Anything in the notes you'd like to talk about today from either the section you're supposed to watch or any of the past sections would be fine as well. Anything in the notes? Okay, so the other question I had from the homework was on 4.2, and that was the video you were supposed to have watched for today. And so 4.2 was about the column space and the null space. Line this up correctly here. And so before we look at this homework question, let me just tell you what each one of those things are. So the null space, this is 4.2, right? The null space are all the vectors x that get sent to 0 when you multiply by a. Okay, so it's the set of vectors. It's all the vectors x that when you multiply by a matrix A, they get sent to 0. So, you're given a matrix A, and then you find the null space of that matrix by solving the homogeneous equation. That's harder to do than thinking about the column space, which the column space of a matrix is just the span of the columns, right? And so if we have a bunch of columns, A1 through AN in a matrix, then the column space would be all the vectors that you can get when you do linear combinations of the columns. And so if you want something in the column space, it's really easy because you just pick constants for the columns and then add them together. So in this particular question, you're given a matrix A, and it has 1, 2, 3, 4 columns. And the column space are all linear combinations of them. So C1A1 plus C2A2 plus C3A3 plus C4A4 for any constants C1, C2, C3, and C4. So you literally just have to pick some constants for this question. So the question here is find a non-zero vector in the column space. And so the answer for this one is just pick any 4 constants for the above linear combination. So for example, you could make all of them 0 and one of them 1. In other words, each individual column is in the column space. Or you could do any linear combination of them as well. So for example, you could do C1 equals C2 equals C3 equals 0, and let C4 equals 1. That would work. Or you could let them all equal 1. Or you could let them be something different. Right? All of these are ways you could find some value or some column in the column space. You literally just need to add some version of the columns together, and that will be something in there. And so it'll be a 3 by 1, and you can see the way you would enter it is entering each entry into the answer. Thoughts about that one though?
I have a question about problem 6 on 4.2.
Sure. Let me switch over to number 6 before you ask it, so I can just be looking at it while you ask. Hold on. Okay. Yeah. So let me just clarify for everyone who was asking what question 6 says. So this is not something that's covered in the chapter, but I was hoping you could extend pretty easily to this question. So this is number 6, and it gives you a vector, or a matrix, excuse me. And it wants a value of a vector in the row space. And so the row space is the same as the column space, just using the rows. And so here we'd have like row 1, row 2, row 3. And so the row space of A would be C1R1 plus C2, oops, that's just not a vector, C2R2 plus C3R3 for any C1, C2, C3. Sorry, maybe this is a simple question, but I did want to just sort of clarify this one. I was hoping, again, row space is not something that's in a section, but it's the same as column space, but for the rows. Oh, sorry, there's 4 rows. I messed that up. Okay, sorry, I didn't mean to interrupt. I just wanted to clarify that, what the question said. So go ahead, ask your question.
That was my question. I just didn't know what the row space was.
Okay, it's the same thing as a column space, but for rows. So just do any combination of the rows, or just pick one of the rows, for example, and that will be in the row space. Other questions, thoughts? Those are good clarificational things, really quick kind of things. I forgot I put that row space one in there. The thing I'll maybe point out is, I hope you're watching the videos and kind of taking class serious. I feel like if you're watching the videos and doing the notes, this is going to be not a problem. It takes some time to do that, but the class will be easy for you. If you're kind of just like trying to work through the material by looking at the notes and figuring it out yourself, it might be challenging. But if you're in that boat, the last page in 4.2 summarizes the difference between the null space and the column space, because they're sort of similar, and you find them in sort of similar ways, right? You're using matrix operations and things, but the way you do them is quite different. And so I'm hoping that this last page clarifies the difference. And this is, I think, a good page to look at to study, basically, to check your understanding of the differences. Other thoughts or questions? Happy to keep talking here. Thank you for preparing those questions. I got a decent number beforehand. I've been emailing with people. It's been great. I'm just going to stop talking and see if anyone else wants to talk. Okay, so there is another question. The last thing I'm going to do is just remind you that there's review material on Blackboard. So I'm going to share my screen real quick. I haven't actually showed you this. So I am going to share my screen. Okay, so I'm sharing my my screen here. Hopefully you're looking at it. And if you go to course documents on Blackboard, and you go to test topics and solutions, there's lots of stuff here for, maybe I did show this already, I can't remember. But anyway, there's lots of stuff for test 1 topics. I already posted final exam topics, and then there's like a nice big review packet to help you study a little bit. And so what we're going to do on Monday, as a quick reminder here, is we'll do a full-on review day. So feel free to email me questions as you're looking through stuff and starting to study. I hope you're starting to study before, like the night before. And then on Monday we can look at review questions, we can look at homework questions. A really good way to review, I think, would be to go through these written problems, right? So the problems that I would have assigned in class if we kept going with the normal class are all right here in the written homework problems. And all their solutions are down at the bottom here. So like, I think that's a good way to sort of check your understanding of some of the stuff, is just see if those questions make sense. And so these are good questions basically to ask about, I guess is what I'm trying to say. If you have some questions about any of these homework solutions, we could talk about those on Mondays too. But I'd really like you to try to come on Monday. I'm going to sort of be taking attendance and everything like that because I want to do a dry run of the test. I've never done a remote test like this before, and I'm assuming you haven't either. And so I'd like us all to be comfortable with that on Wednesday. So on Monday, we'll do a little practice thing. Maybe I'll even create like a couple practice questions, ask you to fill them out, and then submit them. Again, just as practice. So that's where we're at. That's what we'll do on Monday. Feel free to keep emailing me. I'm happy to pop on here and answer some questions, later today or tonight or when you're working on the homework. But I don't sit here late at night. So, the sooner the better as far as getting help. Okay, I think that's all I've got. And I'm going to post this video on YouTube like always. And